Hey everyone! Thank you for joining us for the Microsoft Fabric FabCon Global Hackathon. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you so much for joining.
Hello and welcome. Welcome to this session. My name is Jasmine Greenaway, and I am a senior cloud advocate working on the data advocacy team. I specifically focus on databases, so I'm super excited to present our two folks in the databases space, Idris and Jai. Let's do a round of introductions, and we'll go ahead and move on.
Hey, thank you, Jasmine and Anna. This is Idris. I'm Principal PM in the Azure SQL organization. I focus specifically on SQL databases and Fabric, and really excited to be here. I've been with Microsoft well over 3 years, and excited to share some great stuff with you all.
Hi, everyone. My name is Jai. I'm a product manager on the Azure Cosmos CB team working on our Fabric integrations. I've been with the company for a little over 3.5 years now, initially a software engineer, now a PM. So very excited to be here talking to you all about what we're offering.
Wonderful. Thank you for joining us, Idris and Jai. Before we get into SQL and Cosmos, we're going to talk a little bit about the Fabric Hackathon, and then we will get into these individual databases. So let's talk a little bit about what our session so far, where we are so far in our roadmap. So Hackathon kicked off in mid-September, and now we can see that today is our session, and we have a bunch of other sessions coming up, and that November 3rd is our project submission deadline. So just keep in mind that we are less than a month away from your submissions. So let's take a look at how to get involved. If this is your first session, first live stream session, welcome. You're in the right place at the right time. If you're inspired to join the hackathon, you can go to aka.ms FabCon Hack Register to go ahead and register. If you're in the chat, say hello. If you're looking for somebody to join in a group project or a team, be sure to ask in the chat. And if you are quite new to Fabric or you want to level up your Fabric skills, you can go to aka.ms FabCon Hack Skilling Plan. It is part of the hackathon, so definitely get into that and be sure to complete the skilling plan. And then finally, be sure to submit your project by November 3rd before midnight, so by 11:59 p.m. Pacific Standard Time. And then note the other note here that you may submit more than one project, but each submission must be unique and substantially different from your other entries. So on that note, let's talk a little bit about the judging criteria. If you want to learn a little bit more in depth about the judging criteria, definitely check out the first hackathon or the first live stream in the hackathon series. You can find that here in the Reactor page. So the criteria is hackathon category alignment. Does it fit clearly into one of the categories? Innovation and impact. Is it relevant? Does it solve a real problem? Documentation and reproducibility. Is it well documented? Is it easy to follow? Is it in your GitHub repo? And then finally, does your video clearly demonstrate the solution and how it works and how it uses Fabric and AI? So I want to talk, so there are quite a few categories out there, but I want to laser focus on two in our particular, for this particular session. First is the best AI application. So just to read this off, you need to build a complete solution that uses Fabric's advanced capabilities, such as data agents, integration with AI Foundry or Copilot Studio. It could also include building retrieval, augmented generation apps with the event house, such as vector store, forecasting, anomaly detection, or custom ML models trained in Fabric. The goal is to show how Fabric's AI capabilities can be combined to build something intelligent and grounded in real data. So one thing I just want to highlight here is that both databases that you're going to see today also have vector capabilities. So this could technically be an item in your stack of your solution to win the best AI application. But there is a specific category for databases. So best analytics solution with Azure or Fabric databases. So creating an analytics solution that connects operational databases on Azure or Fabric. This could be by connecting to Azure SQL, Cosmos DB, or Postgres using mirroring, change data capture pipelines, or data flows, as well as Microsoft Fabric's native databases, so SQL and Cosmos DB. So that is another option for you as well. So if what we're looking for is integration with these external data sources or using these operational databases in Fabric directly. And of course, there's the grand prize, which is the best of the best. And so it meets all judging criteria, and it really wows the judges. So so you have many chances to win, many opportunities to win. So I'm excited to see what you all build. So now we're going to get into we're going to get into databases in Fabric, and we want to talk a little bit about why we can reach for databases in Fabric as an option. So let's talk a little bit about this issue of data sprawl. And this is a problem of uncontrolled growth and fragmentation of data across things like multiple tools and platforms, many cloud services and on-prem systems, and it can really lead to issues of redundant copies of data, siloed insights, even security and governance risks. And that can be a really huge problem for folks who are trying to gain insights or even leverage AI. And so the way that, so essentially this ends up being a task that a lot of the folks on, including developers and IT professionals, need to have to deal with. And so there's a couple things that they need to do. They need to understand how to balance performance and cost optimization. They need to, of course, make sure their data is secure and also being accessed by people who need to access it. And then finally, things like backups and updates while maintaining those uptime requirements can be a really big deal when you're especially working with a lot of data. And so the way that Fabric solves this, specifically Fabric databases, is that there's a couple things in here, but I'll touch on a couple things. So first is OneLake. So OneLake is we like to call it the OneDrive for data. So all your data lands in OneLake regardless of its source. So no need to copy or move your data between systems. So whether that be NoSQL data with Cosmos or relational data in SQL, it's all accessible in one place. And the way that you're able to interact with all these different data sources, integrate with all these different data sources, is a SQL analytics endpoint. And we'll talk a little bit more about that a little later, but essentially it's your window into all integrated data. And of course, you have with OneLake, you have things like shortcuts and the ability to create semantic models, and finally, unified governance and security. And so specifically with Fabric databases, kind of touching on things I mentioned before, it's simplified. Everything's in OneLake, autonomous. You can manage your databases right directly into Fabric, as well as, of course, do things like set things on schedules, things that you would normally want to do without having to be hands-free. And then finally, optimize for AI. So any integrations or additional things that you need to do to data to be ready for AI, you can leverage AI directly in Fabric, or even leverage things like I mentioned before, vector data types within Fabric as well. So on that note, I'm going to pass it over to Idris, who's going to talk a little bit more about SQL and Fabric.
Hey, thank you, Jasmine. Can you all see my screen and you hear me well? Yes. Great. Welcome, everybody, and great intro on setting the stage here. So before I get into a little bit of SQL databases and Fabric, I just wanted to talk a little bit about what about Microsoft SQL, how the whole ground to cloud to Fabric has been architected, you're most likely familiar with SQL and its various implementations. SQL on-prem, SQL on cloud, there's intelligent cloud, and we have intelligent ground. What we mean by that is has the ability to connect to the cloud from the ground to Arc. And example, like components you may be using, like the T-SQL engine and the query processing engine. There are tools, SSMS, Visual Studio Code, right? And we have added capabilities now with copilots and AI integrations. As you can see, we're moving SQL from ground to the cloud, from infrastructure as a service to platform as a service, and now to Fabric, which is a SaaS platform. So this naturally raises an important question: why do we build a SQL database in Fabric? So before we get there, a couple of things. We want to truly unlock the power of AI. And the organizations must understand how to combine the operational data, which is where your transactions and your real-time transactions are being written, which you're creating your data. That's what you call the operational data. And then you also have something called the analytical data, which you call historical insights. It could be your near real-time data as well. So traditionally, these worlds have been separated, and it creates a wall. When sometimes like, I want analytical data and I want to hit on the operational data. So to solve this, we have taken this into architecture, and that's a problem for AI, which thrives on both speed and depth. So given that, as Jasmine called out earlier, we have this databases in Fabric. Last year, recognized we announced public preview of SQL database in Fabric. Our data landscape is changing super fast, and we're moving to a siloed system to a unified platform. So Fabric now is a unified data platform, and the next generation of AI application doesn't use a part of your data asset; it requires all of it. So database is now a new feather in the cap out there, and now we're combining the SQLs, and you'll hear from Jay as well about Cosmos as well with Fabric's the modern SaaS-like platform. So let's just get a little bit into detail and see how these currently two products are in preview right now, right? And we get into detail about what the pillars are we built on. So number one, we talked about simplified. But what we're referring to here is, when you create a SQL database in Fabric, we really wanted to take the principle of simplification. We want you to have minimal knobs. You just need to be satisfied operation. Management is easy. As you talked about, the operational and analytical are combined together. It's integrated with all your tools and capabilities like SSMS, Visual Studio Code, GitHub, etc. At the same time, we also wanted to be autonomous, so you don't have to manage and maintain and about the security and the governance and the high availability and zone redundancy. All of these are taken care of for you, and it's auto scales for you. And the other thing you talked about is mirroring to OneLake, and we'll show that in a demo. We have quite a few demos there, so be ready for that. The OneLake is what Jasmine was referring to, the Fabric OneLake. So as and when your operational data is being created, you are automatically getting the data available as a copy, as a read-only SQL analytics endpoint into Fabric OneLake. And we're also optimized for AI. So this is where you'll see a lot of vector capabilities, RAG capabilities built in with Copilot and Azure AI integration. And we'll talk about that as we go through this presentation. So on the simple side, just to drill a little bit more, it's easy to provision, it's AI assisted, there's an integrated T-SQL editor, and it's built on performance. And we will, from an autonomous perspective, we understand that managing database can be complex. It's time consuming. It often requires deep expertise to perform, do performance, availability, security, etc. So we thought of all of that stuff, where every database is automatically configured with high availability, compute and storage scales automatically. And we have mentioned earlier, data is automatically replicated to OneLake as well. So security, as we all know, security has always been one of Microsoft's top priority. With Fabric, we continue that commitment by making sure your data and your applications are secure and governed by default, and same with SQL database in Fabric. The one thing I want you to also understand is the SQL database in Fabric, and we'll talk a little bit about, is based on the same Azure SQL database engine which you're familiar with. So all of the components, all of the capabilities which you have from security and autonomous and the simplification perspective, all of those SQLs are available to you in this. And you can see a couple of items here, like the one we highlighted, auditing, and the one with data encryption capability, customer managed key support. These are coming up soon next month. So get ready for that as well. So authentication is all Microsoft Entra only, right? And it's built with all the network security, and it's also integrated with behind everything with Microsoft Purview, enabling sensitivity labels and protection policies. So under the hood, this is how it works. So if you see the world of Fabric, right, and we have SQL, so there's an orchestration of the whole SQL Fleet Manager and the whole, it's based on a serverless architecture. So there are these predefined, we have created the SQL databases beforehand for you. It has the classic log files, your MDFs and the LDFs and your master data files and the log data files for in the SQL. And then under the hood, that is managed there, and the data from there is connected with Fabric. So it's a perfect orchestration where the power of Fabric is created with the operational databases together. So let's just go peek a little bit into a demo here, right? And see how it goes. So basically, this is SQL database in Fabric and demonstrated in the FabCon VM. We're creating a new SQL database. All you do is go there and go to the child and give it a database name, and you create it. And quickly, what it's doing is behind the scene, it's going to the fleet managers. It's saying, okay, I have a database created, and in seconds, you have a database created. So now you can now look at the database. You can look at the structure. You can actually import data from various places. You can get it from your data flow pipelines. You can get it from a different source. You can get from a T-SQL command templates, or you can get a sample data. I'm going to bring it from sample data, which is our AdventureWorks data. And what it's doing is it's importing the data. It's creating the schema. You can see we have created actually the separate schema, and you see the data in there. You can see the database, the DBO, which is created by default, and there's sample data. So now you can cruise to the tables, you can look at the stored procedures, views, exactly you're familiar with all the various tools. So here we are looking at the table here, and you can look at the data, which is for the product table. Very easy to use. And let's go see something else. Let's go create some queries. And I'm going to create a query now. I've just put it in a comment, and this is where Copilot is actually working. So now, as I just put in the comment, Copilot actually created the query for me, and I'm actually just executing. I didn't have to write a single line of code. So this is where the power of Copilots and AI is coming into the power. Now let's go and let's go create another query. And let's say you might make a issue or syntax issue, like I've created some wrong references. Now you can fix the query errors right there and then from the editor. So it's auto fixes. It actually puts a comment in there for you and says, okay, it's been fixed. Now we ran it. And so the other thing is you can also go and interact with the Copilot thing. So there's a smart query editor, and there's a Copilot editor on the side on the page. Now you can ask and say, hey, write me a query that will return the most sold products. So you can see how interactivity has been built. Query, the Copilot is now giving it, say, okay, this is the query. Would you want to use this? And you can interactively say, yes, let's go. It's an intern editor. So it kind of actually puts it back into the query window, and you can execute from there. And there I am taking it and executing it. So just want to give a little bit of grounding of these capabilities. Now you can create a view as well. So now here's the thing. You can create a view, and you can say, hey, do you want it to create it for me? Or you can insert in a code. There's an option where you can actually create this code directly without even putting in the editor. In this case, I'm putting in the editor and creating the view. Okay. So let's refresh it, and we should have that view created. And there it is. So now let's go. This is the ability for you to go and open in SQL Server Management Studio. You can go into Visual Studio Code. You can open in various tools. You can also create an API, or you can also see a performance summary of how your queries are doing, how much memory is being consumed. This is a new metric which we created, enabled for a couple of weeks back. You can see how your queries are performing. Let's go create a new GraphQL API. So in this case, APIs in the GraphQL API, you're basically writing in JSON from the client side and getting the data back in JSON. So I want to get the products in this case and creating an API right here. So I'm like, okay, let's go and say I want the products from the product table and give it a query and give me the first 10. And here it is. So you also can do the Git integration. So you can actually do either through Azure DevOps, or you can do your ability to connect to your source control. And so you can see a dev cycle. You can take this database and I can check it in and create a SQL project. So it's very seamless, very easy for you to connect your various developer capability as well. And we'll dive in a little bit detail about showing some of the things. Now here I'm showing the SQL Analytics endpoint. This is the ability, the mirroring capability, where you're actually seeing your data, which you just created, is all being replicated. And this is being written, what you see right now is all being written in OneLake, in Fabric OneLake. Let's go close this and let's go switch to the analytics endpoint. Now, this is the read-only endpoint. So this is where we actually, all the data which you have here is written in Delta Parquet format. And you write a query here, and the same query which we executed earlier on the transactional data can now be executed exactly in the SQL Analytics endpoint. So this is a quick glimpse on how the overall kind of a few features of SQL database in Fabric. So what are some of the top use cases and scenarios? So as you're doing the hackathon, you're thinking about, this is our customers, our partners, our users. They're seeing capabilities like creating an operational data store. They are creating event-driven pipeline architectures and applications. Folks are using the line of business Power Apps plus SQL plus Power BI because there's a lot of attached, a lot of capabilities, the analytical and the data coming in there. And because I talked about metadata-driven pipelines, there's a vector and AI application development. In fact, I'm going to show you a little demo in there as well. There's an ability to, you can get the data from the from the data which is created from your Medallion architectures or your gold layer, processed from Fabric through various notebooks, etc., and bring that data back into SQL database and Fabric as well. You can also do Power BI write backs. You can create a reference data store. There are a lot of these capabilities. So of these use cases which you're seeing. So let's go to a little bit more detail. And we talked about the integrated AI application platform. You saw a bunch of, you'll see a lot of these components where you'll see on the left-hand side, you'll see the developer tools, right? And all the foundation of a data layer, right? You can have the Fabric CLI, you can use Terraform, you can use GitHub, you can use GitHub Copilot, and we'll demonstrate that as well. And you can see that all this data moving up the stack, Fabric also provides a strong business logic layer along with the data layer, like the databases, real-time intelligence, all of these capabilities. And then it also, you can create instead of switching over to Azure Functions, you can also use user data functions, for example, directly with Fabric. You can create the GraphQL API, which I just demonstrated earlier. And also, we have the ability to create data agents, right? Which lets you build conversational AI experiences on top of your data in OneLake. So you should be able to take the data which is being replicated in from SQL Database and Fabric or Cosmos data, and then you can imagine being able to ask any questions about your data in natural language, and that's data agents as well. And then there's the app layer, basically for building those full stack applications. You can continue to use Kubernetes, the app service, container apps, all of these API management capabilities, enabling powerful, scalable AI applications that draw directly from Fabric Data Foundation. All right. So talked about the application tools. Let's dig a little bit more. There's in VS Code, which you might be very familiar with. We have the MS SQL extension. This allows you, there's a multi-platform capability. It is available. It says it's got a modern UI and it's got built-in tools. It's a developer-first experience. So we realize that the developers, where they live. So we want to meet them where the developers are. So with that, we have integrated the MS SQL extension for SQL code, and you can interact directly with SQL Database and Fabric directly there. So you can see I'm in a Visual Code environment, Visual Studio Code. I can go to the SQL Server connection, right? And you have the ability to create your own local Docker server, but you have the ability now to create a SQL database in Fabric directly from VS Code. You don't even have to go to Fabric. So the Fabric portal. So this gives you a preview of, say, what this SQL database in Fabric is. You provide the information, you give your database names and your various information. You can create a profile, so you can manage your profile like on Visual Studio Code, and this is like managing your connection strings, or if you have a DTAP environment, so developer test production type environments. And there you go. Just provide the information, and you should be able to go create and you can say which workspace within a Microsoft Fabric it is in. So to create the database within that workspace, you can give some options here, and should be able to. By the way, this uses Microsoft Entra. So let's go and check on that one. It creates a database, and the deployment is in progress. So you can see how the interactivity from a developer perspective, it actually is creating it, it's provisioning it. The same thing which we actually saw there. Now it's creating and connecting and gives you the database, and it's finished the deployment. So again, in seconds, it's out there, and you can now go back to the extension. You can look at the database which has been created, which you just gave a name, and we can actually move it in there, right? And then we can actually go and connect to the existing database. So one was creating it. So once you go, we can actually go back. This is the ability for you to go back and give it a name. And you can say, okay, if there's an existing database, I want to go into my workspace. You can see on the left-hand side, it's navigating. It's giving you the ability to connect to your workspace. So here I'm connecting to the database which you just created, right? And say, okay, look, this is the one which I'm going to connect to, the one we created, right? And go from there. Or I can even connect the one which might already be in a different workspace from there. So connect it, sign in, and you should be able to go connect. And there it is. So you'll see your SQL database which you have created, and you can actually move it up into your connection string so you can manage it all in one environment. So with that, we also have the ability to get a Copilot integration, so which allows you to talk with the Copilot from GitHub for schema-aware interactions. If you want any kind of show me some data, inline suggestions, you can do agent mode tools, all of these capabilities, and natural language prompts. So let me show a little bit, and also does the code generation on this one. So in this case, what we're doing is we have created a database already. There's a table structure in this, and I'm going to ask to say, you know what, give me a context and give me the schema design so I can validate. So I'm invoking the MS SQL extension, right? And I'm going to say, okay, show me the schema for the database, which for all the databases which I've created in my FabCon database, right? And here it is. It's going back and say, hey, it's interacting with you. You know, it's going to display the schema of your databases for what you have asked for. And you can see that, hey, there is a name of FabCon server in your list. It has a connection string. So that brings it up, and it's actually generating the schema designer for you. So you're interacting with your database's schema directly from here. You have to give the prompt to allow. So now here you see that I can see the relationships between different tables, which I've created here. But in this case, I was there's a session table, there's a speaker table, there's an agenda table for the session which we were making this database for. And you can say, hey, let me now show what some of the data, some data I want to query directly from. So I'm interacting with the Copilot, or the query the data for the speaker table, right? You didn't have to go and write a SQL query. You're just asking Copilot. So you just see you're interacting. It says, hey, this is the data set. There are these 6 speakers in this. It's giving you the output. So you're interacting it very closely. So think about, as you're developing your applications, right, how you can interact and do advanced capabilities with GitHub Copilot integration as well. Okay. All right. So we also want to talk about, we have this new Spark connector for SQL databases. We just announced this a couple of weeks back, right? This is a very high performance connector. So folks have asked us, hey, from my notebooks, how can I connect to SQL database in Fabric directly? And, previously you could just connect to your SQL Analytics endpoint. Hey, I want to manipulate the data. So now you can, it comes pre-installed, right? It's you can use with your simplified PySpark and Scala, right? It supports multiple authentication methods. It also works with all the other SQL databases as well, besides Azure SQL Database and Fabric. So Azure SQL Database, Azure SQL Server, or Azure VM, it works great. So you can bring in your other flavors of SQL as well if there is data out there, and connect with Fabric SQL as well, SQL databases and Fabric as well. So please do take advantage of that as well. So now last but not the least, we talked about the optimized for AI pillar. So here what we're talking about is building scalable AI applications with Microsoft Fabric with RAG support. The RAG is about combining the reasoning power of LLMs with the precision of our enterprise data. Instead of relying solely on pre-trained knowledge, we use semantic search to retrieve relevant data from a SQL database in Fabric. So the model generates an answer that are grounded in our data, which gives you actual business context. So that's how it works, right? And every piece of data, we'll talk about it gets turned into something called an embedding. An embedding is an array of numbers, which is also called a vector, and those numbers capture the semantic meaning of the text. And we'll shortly see in a demo, and the distance between the two vectors is close together. If it's closer, it means they have a similar semantic meaning. So for example, if you see cheetah and tiger, right, they have a more close similarity score. But if you have a mat and a bat, it will not have a score which is it will have a score which is not as close. So we'll see that we have the semantic search capabilities which is built in, and what makes it even more powerful is that Fabric makes this process very, very seamless, right? So you can run the data science workflows in Notebook, you can prepare and orchestrate your data using pipelines and data flows, and visualize it all as well. So let's just see some of that in action. So this is, I was talking to my team over there and said, now let's go, this is a hackathon thing, so let's go get some data from Kaggle, and let's do some capability of smart recruiting. We have this scenario where there's a recruiter, there's a candidate. We built an agentic AI app where we can screen, we can get the resumes of candidates who are looking for opportunities, and how an agentic AI can help use this capability of getting this data into Fabric, leveraging all the native vector capabilities and Azure Document Intelligence and OpenAI with Fabric. So we want to really empower the human agents to spend time more on identifying the right candidates, so we can looking for efficiencies and more intelligent decision making. So I'm going to walk through quickly a demo here. So here we have, we are started by uploading all our resumes in like PDF format, again from a Kaggle data set. We are putting it all into an IT information technology folder, and this is on the notebook. So I'm bringing it all out there, and here you can see that one of the PDFs, which kind of looks like we'll be extracting the content from. This has the data. This is all the text. So we're going to be extracting the chunk text from the PDF. I'm going to use a Fabric notebook because they're very easy to use. And we'll go ahead and provide the input documents. So now let's switch over to the notebook and say, excuse me, to something called a analyze document API, right? And so we'll go down there. And we're going to be extracting those texts from the PDF. And this is really powerful because the files are already in the Lakehouse, and we are going to be using the pre-built model here, which is one of the best parts about using the Azure Document Intelligence. So you can use it with common document templates like invoices, receipts, a lot more. So you can be creative with your ideas here. Don't need to spend time training your data. It's like having a team of document experts. So here we go. We are going to chunk it all, extract all the text, and we just ran this thing. So now you can see that there are 120 files in the directory for where we load it. For each file, you see it has gone ahead and created chunks. So I can see the unique chunk ID, the chunk length, and the chunk text itself. Okay. And it gives you the particular file, where it is coming from, and what the details behind it. So let's go into the next one. And this is part two. This is where we're going to create the embeddings. Remember, we talked about the embeddings earlier on. So here, it's going to basically, each of the chunks we created from here, right from where all the Fabric notebook, I'm able to create embeddings directly. And these are the numbers we're talking about, the embeddings number. And we're going to put it into the vector type soon after this. So once we have that, the next step is to actually go and put it into SQL database in Fabric. How we do that? So here we go. So, and Azure SQL DB now supports the native vector capabilities, and you're all going to be developing AI applications, and so sorry, can play this, right? Here's a quick look that we're going to actually store this. We're creating a table and storing all the resumes in there, right? This is a native SQL DB and Fabric, and it has a chunk ID, it has a file name, and the embeddings. So you can see here, I have a table with the embedding stored, and I have a search query that says, hey, now I want to maybe look for a capability where say, see here, okay, yeah, there you go, the chunk information we're talking about, and the embedding. And because now this uses a hybrid search. So because this is SQL DB, you can also use additional filters besides the vector distance. This is the vector distance function, which gives you, say, hey, show me the data which is coming from the capability for, and getting the embeddings for, I'm looking for the word database administrator for the model which I have created, right? And return from that particular table which we have just loaded. Now, because it's hybrid search, right, you can also add you can add your where clauses and your typical filters which you would use. In this case, say, hey, show me the one which is the information technology, and also show me the ones which has the word SQL. So you can combine both of these, and we're calling the embedding model here, and this runs a query, and let's see the results. So you can see now it's actually got the semantically most closest to information from each of these resumes. And you can see that it actually brought in a word called DBA. It says state DBA, even though it did not know what DBA is, but it knows that DBA in the embedding and the similarity capability, that it's same as database administrator. So it's now, it says the similarity is 0.84. So as you see the number 0.84, etc., it's closer to 1. That means the more powerful, closer to the similarity to what you have provided your query with. So what's next? So here now we can do is let's make this one step better. Now let's build the agentic AI we talked about. So we will here take the capability, and we're going to use a model like GPT 4.0, ChatGPT 4.0, and we can now get more context. So I'm going to now define a system parameter here. We're going to actually create a prompt over here, and I'm going to make it a little bit casual and intelligent to say, hey, show me all the similarity score from the search results that have been passed. I'm also going to add a little summary and say, hey, show why the candidate may be a good fit, even if exact skills are not matching. So it's like, so let's look at how that performs. So I've defined a function here, right? And I'm actually going to go be providing the user input over here. So let's say I'm looking for, let's say, a product manager for the Azure database migration team, and maybe candidates should have good experience for the migration projects, right? And PostgreSQL and Oracle, along with some SQLDB experience, right? So I'm kind of looking. So I'm creating this prompt. Some agentic AI is getting. We can feed all this information. So let's see how this kind of responds to us, and let's run that. So the model has been created, right, with the context, and let's go run against our data which we have. So now we can see that it's checking with the SQL vector search results. It's going to now return the answers. There you go. It's asking what roles you're hiring for, and there you go. So it gives you the top 3 candidates, and it says that it's the candidate's file name, their chunk ID, the similarity score, right, and what you might be, and a summary of you might be interested in as well. So it actually also gives a little bit more grounding on some other things coming from those resumes which you might be interested in. So it also says that the candidate also has an extensive experience in database migration projects in this case, right, and a broad range of capabilities, including SQL projects. So it took all the words semantically, combined together, gave you your top 3 things, and also gave you a fun fact about which is interesting, which I thought it's very, very interesting on this, that the migration service is here and how it supports seamless integration migrations from various database sources. So pretty cool, and that this is how we're seeing the whole orchestration between Fabric, Azure OpenAI, and AI Foundry services, SQL databases, and Fabric all together working in Notebook. So everything what you see here is part of SQL database and Fabric. So with that, these are some resources, and folks, if you can share with the folks on the chat here, will be great about Fabric databases. And that I'm going to pass it over to Jay. Thank you.
Thank you. Before we do, Idris, just a couple questions for you. And anybody in the chat, feel free to send some questions in. We'll be eyeing the chat. Idris, Fabric is about 2.5 years old, and your team and SQL Database was the first database to be added to the into the database's workload. Can you tell us a little bit about that journey and like what the customer need was there?
Sure. Yeah. So one of the main pain points and the challenges customers are asking us, hey, we have a lot of knobs, a lot of configuration things we have to do on our task set for Azure SQL DB. We want the ability to get the data closer to analytics and get derived insights. We have to run all these AI models, and we have to run all this reporting. So how do you provide that workload isolation? Can I come up with a product and we don't, and I have to stitch all these things together? So that stemmed us from like how can we bring this thing into Fabric platform, make the architecture so seamless, and make it available to our customers and users, and they're seeing a lot of value in there.
Wonderful. Thank you so much, Idris, for your presentation and for answering that question. If you have any other questions in the chat, Idris and team will be able to answer them. We're going to pass it over to Jai. Jai, are you there?
Hi.
Hey there.
Thank you so much.
Yeah, welcome. We're going to let you take over and let you present on Cosmos DB and Fabric.
Awesome. Thank you. Thank you so much, Idris and Jasmine. It just did a fantastic job kind of exploring the full depth and breadth of Fabric and everything that you can unlock. So today we'll look at how Cosmos DB supports generative AI workloads, how customers are using it, and how it connects with Microsoft Fabric to unify operational and analytical data for real-time insights, kind of like what Idris mentioned for SQL as well. So I'll also walk through a quick demo using database mirroring and Fabric notebooks to analyze chat history data as well and look at some chat sentiment analysis. Feel free to drop questions in the chat and our team will be more than happy to answer them. So AI is everywhere. It's here to stay. That's kind of what we're really trying to dig into with Fabric here. Over the next 3 years, 92% of companies plan to increase their AI investments, and many of you are already exploring it in your own hackathon projects. So as the industry evolves, we need databases that can adapt just as fast. And this is kind of where Cosmos DB comes in. And for those that are not very familiar, we're a highly scalable, highly flexible database. In terms of workloads or AI workloads, they aren't like traditional apps. They're dynamic, data hungry, constantly evolving and changing. You're processing all sorts of, data, chat logs, embeddings, events. And so you need databases that can kind of keep up with this demand. And Cosmos DB delivers that foundation. It scales instantly to handle unpredictable workloads, whether you're running a handful of agents or millions. It keeps latency under 10 milliseconds anywhere in the world, so your applications stay responsive. We also have 5 nines of reliability. It's completely schemaless, which means your data can evolve as fast as your models do, so there's no downtime. And because vector indexing and search are built right in, Cosmos DB lets you store and query embeddings directly inside the database without extra sort of infrastructure. So Cosmos DB really combines the speed, scale, and flexibility into one platform, providing the backbone for building AI-powered apps. So let's look at how some of the biggest innovators are already using it. Um, so one you may be very familiar with is OpenAI. So OpenAI has relied on Cosmos DB since day one. Every single chat GPT session is stored and served through Cosmos. And it's how they support hundreds of millions of daily conversations and at petabyte scale while keeping the experience fast and reliable. And that same sort of flexibility and reliability is driving innovation across industries. So we see here many different use cases from many different customers. I've linked kind of all of the articles talking through all of these. I'll ask Jasmine how we can share this afterwards, but it's really interesting, and I suggest everyone check it out to just see the architecture surrounding how customers are integrating Cosmos DB. And so these examples show the range of what's possible from retail to healthcare to automotive, and they're all running on that same scalable, low latency foundation. But everyone's moving fast on AI, but most are still struggling with the data side of things. It's not about having more data; it's about managing this sort of complex real-time data across systems. And so the real challenge is connecting the operations and analytics so AI can actually deliver meaningful insights. And this is kind of where Cosmos DB and Fabric comes in. So Cosmos DB then becomes part of this unified data platform. It brings the flexibility and global scale of a distributed database together with built-in analytics, AI, and real-time intelligence. Um, and I won't go too much into this because it just did a fantastic job kind of diving into the why and everything that is unlocked through databases and Fabric. But you know, we're seeing operational and analytical data live in one sort of unified place, and that just makes it a lot easier to make use of your data without any additional sort of pipelines. Um, you get to integrate across different databases. It's much simpler, so everything runs securely in that Fabric workspace. It's fully managed, and everything is connected, so you can enable a lot more advanced scenarios in that case. And that's kind of the promise of mirroring and Cosmos DB and Fabric. You're unifying this data across systems, and you're streamlining the management. You're making it easy to build sort of intelligent real-time apps in one cohesive place. And among Fabric's innovations, database mirroring really stands out as a game changer because it eliminates the need for that complex ETL, pipeline and delayed analytics. That first major benefit is that it's zero ETL. So, every transaction, update, insert from databases like Cosmos DB is automatically mirrored in Fabric OneLake. So again, no pipelines, no batch jobs, no sort of added infrastructure, and that leads to reducing complexity because it really simplifies the architecture and lets teams analyze this sort of live data without extra integration work. And lastly, it ensures that your data is consistent. Your analytics, dashboards, and AI models all run on the same live data as your applications. So, in short, database mirroring really does unify the operational and analytical data securely, automatically, and in near real time. And just a high overview look at just some of the available features that we have across Cosmos DB and Fabric and mirroring. We have Entra-Auth support for added security, built-in AI integration. We have that native vector, full text, and hybrid search, schema evolution, auto schema inferencing, and many, many other features. I highly suggest checking out the documentation to see, all that we offer. And then some features coming very soon. So we are working on the current 8 kilobyte limit for SQL Analytics endpoint documents, because we know Cosmos DB tends to be very heavily nested data. And we have a 1 megabyte private preview landing before the end of the year. And then we're hoping to land 2 megabytes in early of next year. We also have VNet support landing very, very soon. We're continuing to work on our mirroring performance to make it as fast as possible for our customers. So you'll see reduced time for initial snapshot replication to complete. And we're even working on separating that TTL from OneLake so that OneLake can serve as a cold storage, and we can kind of mimic the same behavior that we're seeing in Synapse Link as well. So shifting gears a bit and kind of diving into this demo, we'll look at a real use case to see, all of this in action. We can see how Cosmos DB and Fabric and mirroring work together with other Fabric tools to generate insights from chat history. So let's imagine an e-commerce company using Cosmos DB to storage chatbot data. So the goal here is to analyze those chat conversations to understand product feedback and improve sales strategies. And if you want to follow along as well, the links to the demo are here. You can also just scan the QR code as well to get to the demo material. But here's what, a sort of typical conversation or interaction may look like between a user and a bot. Maybe they're asking for product recommendations, maybe they're giving product feedback, and all that data lives inside Cosmos DB as unstructured JSON documents. And with mirroring, that operational data automatically flows into Fabric OneLake, ready to be explored through these sort of Fabric tools downstream. And so, what are some of the business questions we want to answer? Well, stakeholders want to use these chat conversations to guide decisions in a data-driven way, not just rely on gut instinct. So, for example, maybe we want to look at how customers feel about pricing trends. Do they feel like things are overpriced or underpriced? Is it a good time to do a promotion or something like that? Um, we may even want to track specific brand performance and see how they stack against each other. If a brand is underperforming, maybe we want to do more targeted marketing campaigns to help with this. And in addition, we can see customer direct feedback on the product. So, are there quality issues? Are we getting sizing complaints, and things like that? Making sure that our customer satisfaction is where we want it to be. So all this information is kind of hidden in natural language, unstructured chat, and that's where Fabric really shines. We can turn all this messy conversational data into really clear, actionable business insights. So this is kind of the goal of our demo. We're going to go from this chat all the way to these kind of very easily digestible and understandable reports on top of it. And before we jump into the demo, a quick note about the data sets. We are using synthetic data. If you're interested in how we generated the data, the full prompt and setup are linked here on the slide. You can also scan the QR code as well. So high overview of the overall sort of solution architecture. Here on the left, we have this chatbot kind of feeding its chat history into Cosmos DB in Fabric. And that then is automatically being mirrored into OneLake. And once that data has landed in OneLake, we can create that shortcut in the lakehouse, and then that unlocks so much more downstream. We can use Fabric Spark environment to run deeper analytics, and these Spark notebooks let us call Azure OpenAI directly for sentiment analysis, keyword extraction, any other sort of AI-driven insight. And once that analysis is done, we can build a semantic model and visualize the results in Power BI. So that kind of gives us sort of an end-to-end view here from that raw chat data to AI-driven insights and dashboards, all within Fabric, which is really, really amazing. So let's first focus on this first part here. And it just kind of showed this a bit in his demo, but essentially we're just creating this database artifact, naming it, and just like that, we have a database in our Fabric workspace. For the sake of this demo, I'm just kind of showing the container creation process. Uh, Even if it's optional, you can also add vector embeddings as well. For this specific use case, we won't be, but maybe for your use case. And then I create these other containers to cover both the chat history and the product catalog. I then show kind of uploading the data set, and you can see that it loads instantly. It's very, very fast. Um, and kind of skipping here. So we see the chat history data loaded. I'm kind of showing the data structure here at the top. We see this sort of metadata. That's just from the LLM that we use to create the chat history. In the Python notebook, we're only going to be looking at the messages. So we are kind of simulating raw chat history in that sense. And once this data is loaded, we can even check our replication as well. I'm showing the product data structure as well. Very typical kind of brand name, price, things like that. Um, let's see here. So we check the replication to see its status. It's landed in OneLake. And then we can also switch over to the SQL Analytics endpoint to see that the data has landed there. We can do all sorts of queries, like it just mentioned. This is a read-only, but you can, explore your data here as well. We can run this sort of top 100 query already built in. But this kind of highlights the sort of data store and mirroring to OneLake. Then we'll go to our workspace, create a lake house, and then create that shortcut. So I'll skip here just for the sake of time. And like I said, once that shortcut is created, we can then run Spark notebooks on top of it, which really unlocks so much in terms of what we can do with this data. So here I'm just selecting the different tables needed. Um, we'll see that it landed. So we see that it landed in our lakehouse, and we can move on to the chat analysis portion. So now we'll focus on this kind of the bulk of the demo, which is this Python notebook that uses OpenAI ChatGPT to do the analysis for us. And just kind of a quick overview of essentially what we're extracting from this chat conversation. So if we look at the right-hand side here, if we have a customer that says, I like this watch, its design is solid, it's very usable, the price is reasonable, I like the brand, I just wish that there was more color options. We see all of this sort of extracted information below, summarizing kind of the most important key points of the conversation. It allows us to dive deeper into what customers are saying and what they need in terms of our product or our brand. And you'll see later that this sort of structure is what we ask ChatGPT to output. So I'll go here. And this is just me loading the Python notebook from the demo sample. Now we're in the notebook. Make sure to add your lakehouse as a data source, and then you can pretty much run it from there. Just make sure to change the references for the lakehouse name and your Cosmos DB and Fabric endpoint. But this should run right out of the box. I don't know if I have full time to kind of walk through the entire notebook. Um, The notebook itself is very, very detailed and kind of walks you through every step. But high level, we load the data into a Spark data frame, and then we extract these sort of feature level sentiments using Azure OpenAI. So you see here, this is a prompt that we're feeding in. We're saying, hey, you're an expert business analyst given a customer chat conversation, identify the product, its features, whether they liked or disliked it. And we see that output here that I highlighted, it matches the same sort of structure that I showed in the last slide. And I'll kind of skim through here a bit. But we can see here the outputs that the LLM produced. And the rest of this notebook is essentially cleaning up this output, applying a schema to it, applying it, and joining it with our product catalog data. So it's kind of all cleaned up. And then we write it back to the lakehouse and also write it back to our database in Fabric. So there's also this kind of reverse ETL scenario as well. And I'll kind of skip through that. Let's see. So here we see the write back to the lakehouse table and also to the database itself. I'll show here we refresh the table and we see now the new table with the analytics and the chat analysis. And then we can also go back to the database and see that as well. So you can actually refresh it and see that the data has landed. So now you have the data written back to 2 different places for different use cases or purposes. And so that kind of wraps up the analysis portion. We've taken that raw unstructured chat message and turned it into more structured, actionable data. And now we'll look at how to visualize this through Power BI. So this is kind of the last portion. And we'll switch over to the lake house. Here we see kind of the goal here. We want very easy to understand dashboards and metrics. And here we can go to our lakehouse endpoint. It's as easy as creating a semantic model. So you'll see here, we name the semantic model. We've already done the sort of table relations in the notebook. So you really only have to select the chat analysis table, which really streamlines the process and makes it a lot easier to build reporting off of it. And then once that semantic model is created, you can go back and switch over to it, and then you can create a report automatically. So it's that easy to really go from this raw data to full reporting, all within Fabric. In addition to this, you can also use Copilot as well to build additional reporting pages. I'm not a whiz in Power BI, so this is very, very, very helpful. But you can see here, if you wanted to compare brands, for example, and look at how they're performing, it'll create this page entirely from scratch, which is really awesome, really cool, and very powerful. So this kind of concludes the Power BI portion. We've gone end to end from the sort of raw chat data in Cosmos DB to real-time AI insights and an interactive dashboard. And again, you can find all this demo material in GitHub in the previous slide. To learn more, you can visit our Learn Docs and also visit our samples gallery. Our team is working really hard to produce even more samples for different use cases of all kinds. You can even check us out on YouTube as well.
Thank you so much, Jai. Well, I know we are over time, but this has been jam-packed, amazing content. I'm going to quickly take over. If you all have any questions for Jai in the chat, go ahead and Jai and the team will answer them in the chat. And also remember that we did have the repositories for both of the SQL and Cosmos demos in the chat. So definitely check that out. I'm going to close up with a little bit of this idea of the SQL analytics point and just being able to integrate your data. Remember that one of Fabric's goals is to unsilo your data. So we're going to take a small little demo look at cross database queries with both of those Fabric databases. So I'm going to hop here into Power BI, or sorry, not Power BI, but in Fabric. And what I have here are two databases. I have my customers database that has some customer information, some customer data on in a Cosmos DB container, and then I have a SQL database with some customer orders in a table. And so what I'm going to do is run a quick cross-database query. One of the first things I want you to notice here on the top right is that I have swapped to my SQL Analytics endpoint. You can do this in a warehouse or a lakehouse, or directly in Cosmos in Fabric or SQL. Fabric in Cosmos SQL. You can just swap between the two. You can see I started in the Cosmos DB database, and then I swapped to the SQL Analytics endpoint. This is kind of your window into all things integrations with data. So what I've done is I've done a join here between the orders and the customers here. I'm joining on their customer email. So who ordered it based on their email, and then where that customer is. So I'm going to go ahead and just run this query real quickly. And we'll give that a moment to run here. But what we'll see is just the orders by customers, and there we go. Now, what I asked Copilot to do was I asked it to identify some trends and some opportunities to look into insights in my data. Remember, this is relational and NoSQL data that we're doing with this. This is really awesome. And Copilot was able to pick this up and take a look at some things that I should take a look at. I actually already ran Copilot already, and I asked Copilot to look for the total order amounts by region. And this is what I have here in the comments here, actually. You can see that it kind of gave me some steps on how it got to this query, and here's the query itself. So I'm going to go ahead and run that. And what we have successfully done is done a cross-database query between relational and non-relational data to get some additional insights from our data that might be kind of, in different formats, and be able to still find some value out of them no matter what the shape of your data looks like. So that kind of just explains the power of what Fabric can do, and Fabric databases as well can do. So to wrap up, if you want to learn a little bit more about Fabric databases, these are the links that Jai and Idris shared earlier. So you can just go ahead and take a screenshot or come to us later and visit these links and check it out. And finally, if you want to learn a little bit more about skilling, or just skill up, level up, or learn a little bit about the Fabric Hackathon, you can definitely check out these links here. Highly recommend you check out the Discord. We are answering questions there, and you can also chat with us and show us what you're working on. Find a team member as well. And finally, here are some additional QR codes for those links that I shared earlier. So that is it. Thank you all for staying a couple minutes over with us. Really appreciate your time today. Thank you to Idris and Jai and the SQL and Cosmos team for joining us in the chat as well. We'll be around to answer any questions at the end here just in the chat, but we're a little bit over. But I really appreciate your time. Idris and Jai, any closing words before we sign off?
Thank you so much for having us.
Go ahead, Jay.
I was going to say along the same lines, thank you so much for having us and letting us kind of showcase everything we've been working on in terms of our Fabric integrations.
Yeah, and I think the key is, I think data is like the base for any of your capabilities, be it analytics, operational AI, and you have the capabilities, the tools, the platform to integrate it all together. And I think all the things which we all have shared, you should be able to go ahead and create some amazing solutions out there.
Great. All right, everyone. Thank you all for your time, and see you online.
Thank you.
Thank you.